What if the secret to surviving a structural wildfire was to burn your lumber before you ever started building with it? Because a centuries-old Japanese technique called Shou Sugi Ban turns cedar planks into a fireproof exterior cladding by charring the surface to a deep black layer of elemental carbon that outperforms modern chemical retardants in every measurable test. And that does not off-gas, leach, or degrade under UV the way intumescent coatings do. We are going to walk through 5 parts that explain exactly what Shou Sugi Ban is and where it came from, why burning wood actually makes it more fire-resistant rather than less, what the controlled torch hand brush process looks like in real practice, what the side-by-side fire test shows when untreated cedar and charred cedar are exposed to the same flame source, and how the technique has been adopted in modern 2026 architectural practice for wildfire-prone regions of North America, Australia, and Southern Europe. Shou Sugi Ban, sometimes transliterated as Shou Sugi Ban or Yakisugi, is a centuries-old Japanese technique of charring the surface of wood, typically cedar, cypress, or pine, for use as exterior architectural cladding in residential and increasingly commercial buildings. The technique has been traced in Japanese building traditions to at least the early 18th century, with some researchers arguing for earlier origins in regional Japanese vernacular practice that predate the earliest written record. In its traditional form, the technique involves binding 3 or 4 cedar planks together into a triangular chimney, lighting the inside on fire, and allowing the flame to char the surface uniformly while the chimney geometry ensures even exposure of each face to the heat. The resulting planks are then brushed, washed, optionally oiled, and used as siding on traditional Japanese farmhouses, on rural outbuildings, and on the agricultural structures that still dominate the historical landscape of the Japanese countryside. The technique fell out of widespread use in Japan during the 20th century as chemical wood preservatives, as pressure-treated lumber, and as other industrial alternatives became widely available, and as the building trades moved toward materials whose performance was documented through standardized testing rather than through centuries of empirical observation. The visible blackened aesthetic, once associated with rural Japanese vernacular architecture, became a niche choice rather than a default exterior finish. And for several generations, the technique was carried forward mostly by craftspeople who valued the look and the properties rather than by the mainstream Japanese construction industry. In the early 21st century, however, the technique was rediscovered by contemporary architects and by sustainability-oriented builders, partly for its fire-resistant properties and partly for its distinctive aesthetic. And by the mid-2010, Shou Sugi Ban was a globally recognized architectural finish with manufacturing operations in Japan, in North America, and in Europe producing charred wood, cladding for high-end residential and commercial projects. The technique's modern revival has been driven by several converging concerns that make its properties newly relevant in 2026. Wildfire-prone regions in North America, in Australia, and in Southern Europe have produced sustained public interest in fire-resistant exterior cladding that does not depend on chemical retardants that can off-gas volatile organic compounds, leach into soil under heavy rain, and degrade under sustained UV exposure. Architects seeking sustainable, low-maintenance, and visually distinctive cladding have found Shou Sugi Ban to satisfy all 3 priorities at once, and researchers studying building envelopes and fire dynamics have added quantitative testing of the technique's actual performance under controlled burn conditions, supplementing the long anecdotal record with reproducible scientific data. The first of our 5 main parts covers the secret logic of burning wood, which seems paradoxical at first encounter, but resolves cleanly once the chemistry of combustion is understood in concrete terms. The use of high-temperature flame to make wood safer from future fire seems paradoxical on first encounter, because fire is exactly the threat the cladding is intended to defend against. But the resolution of the paradox lies in what the flame removes and what it leaves behind at the surface. Wood is, in approximate chemical terms, a composite of cellulose, hemicellulose, and lignin, with smaller amounts of extractives and minerals distributed through the cellular structure. And the components that are most readily combustible are exactly the components driven off during controlled surface charring. The volatile gases, the oils, and the tars that would otherwise be released when the wood encounters a real fire are exactly the components that the torch flame has already driven off during the controlled carbonization. which means there is less fuel left at the surface to support combustion in the next fire. The remaining surface layer is predominantly elemental carbon, which is markedly more difficult to ignite than the original wood surface, because elemental carbon requires much higher temperatures and much more sustained heat input to enter a self-sustaining combustion reaction. The aesthetic that emerges from this transformation is striking and has become one of the technique's most distinctive design features. Properly charred cedar, when brushed and optionally oiled, produces a deep, almost obsidian-black surface with visible grain texture preserved through the brushing step, and the color is stable under UV exposure in a way that achieves a living patina over decades, rather than the chalky degradation common to stained or painted surfaces exposed to the same conditions. Architects specifying Shou Sugi Ban today cite this patina as one of its principal advantages over conventional siding, because the cladding evolves visibly with age in a way that owners tend to find attractive rather than degrading, and the surface can sit in service for decades without requiring repainting, restaining, or retreatment of any kind. The contrast with conventional construction practice in wildfire-prone regions is real and important. Modern construction in those regions often relies on chemical fire retardants that include intumescent coatings, pressure-impregnated retardants, and topical sprays, and these products can degrade under sustained UV, can leach chemicals during heavy rain events, and can off-gas during the curing phase and sometimes during their service life. Shou Sugi Ban uses no chemical retardant and no synthetic surface treatment in its traditional form because the carbon layer itself is the protection. And the implication that some observers find most controversial is that this ancient approach outperforms at least some of its modern alternatives on multiple parameters at once, including fire resistance, pest resistance, UV stability, and end-of-life biodegradability. The second part of the story covers the chemistry of the char and what the pyrolysis process actually does to the cellular structure of the wood at the surface, where the protection matters most. The pyrolysis process that converts wood to a carbonized surface begins at approximately 200 to 300 degrees Celsius, where the less thermally stable components of the wood begin to decompose in measurable ways. And above approximately 400 degrees Celsius, the decomposition becomes more aggressive, and the surface layer of the wood converts to a carbon-rich char with a substantially different chemical composition from the uncarbonized wood beneath it. In a controlled Shou Sugi Ban process, the exposure is brief, typically seconds to a couple of minutes per surface section, and the depth of the carbonized layer is typically less than a millimeter, sometimes only a few tenths of a millimeter, which is enough to provide the protective sacrificial layer without compromising the structural integrity of the cladding plank. The carbonized layer functions as a sacrificial thermal barrier in subsequent fire exposure. In a real fire encounter, the char layer absorbs heat and slowly oxidizes at the surface. But the rate of oxidation of the carbonized layer is markedly lower than the rate of combustion of the underlying uncharred wood, which is the key protective effect. The char layer is also mechanically stable and crack-resistant when properly produced through controlled torch application and proper brushing, and it adheres to the underlying wood through mechanical interlocking and chemical adhesion rather than through any kind of applied coating, and does not flake off under thermal cycling or weather exposure over decades of service in the field. The net effect is that heat penetration into the structural wood is slowed under fire exposure, and ignition of the underlying substrate is delayed or prevented depending on the duration and intensity of the fire exposure, with thicker char layers providing longer delays and thinner char layers providing shorter delays that nonetheless significantly exceed the response time of untreated cedar siding. The cellulose and sugar removal from the surface layer has a second important effect beyond fire protection. The chemical components that insects and fungi use as food are no longer present in the surface layer after controlled charring, which removes the substrate those organisms depend on. Termites and other wood-boring insects attack untreated wood by consuming cellulose as their primary metabolic substrate. And with the cellulose removed from the surface layer, the char is not palatable to them in the same way, which produces a measurable resistance without any insecticide or chemical treatment. Fungi that decompose would use the same cellulose and hemicellulose components as their metabolic substrate, and the removal of those components from the surface strips the food source that those fungi depend on, which produces a meaningful resistance to rot and to surface fungal colonization without fungicide treatment. The hydrophobic transformation that occurs at the same time is observable in everyday handling of properly charred planks. A water droplet placed on properly charred wood beads up on the surface and sits there rather than absorbing into the cellular structure, which is the same kind of beading behavior that high-end exterior stains are designed to mimic, but rarely achieve for any sustained period. The water resistance is not permanent in the strict sense, because over multi-year exposure, the surface will eventually absorb water, especially if not oiled, but the immediate post-burning hydrophobicity is dramatic and is one of the most commonly cited early indicators of a properly executed carbonization. The mechanism behind the hydrophobicity is partly the closure of the wood pores during the rapid thermal shock of the torch, and partly the chemical change in the surface itself, as the cellulose and hemicellulose are converted into a less water-attractive carbonized layer. The third part of this story covers the actual mechanics of producing the charred surface with a controlled torch, with a brush, and with optional oil, because the technique is reproducible by skilled tradespeople with appropriate equipment, but is not something that should be attempted without preparation. DIY and small-scale application of Shou Sugi Ban typically uses a high-output propane torch, not a low-heat paint-stripping torch, but a torch rated for several thousand BTU per hour, so that the surface can be brought up to the carbonization temperature quickly and uniformly across each plank. The operator passes the torch flame over the wood surface in a controlled sweep pattern, charring the surface to a uniform depth without setting the underlying wood on fire, and without burning through the plank during the sweeping motion. The skill is in pace. Too slow a sweep and the wood ignites and burns through, producing a wasted plank and a potential fire hazard. Too fast a sweep, and the surface is barely discolored, and the char layer is too thin to provide meaningful protection. Brushing is the second crucial step, and is what gives the final cladding its distinctive appearance. After cooling, the charred surface is brushed with a stiff bristle brush, often a wire brush for hard, heavy char, sometimes a softer brush for lighter char, both to remove loose soot and to expose the grain texture in the desired direction. Brushing depth also defines the final aesthetic in reproducible ways. More brushing produces a more textured wood grain visible finish. Less brushing produces a deeper, more uniformly black finish. And the choice is partly aesthetic and partly functional, because a lightly brushed surface sheds water more readily than a heavily brushed surface in some test conditions. Oiling is the optional third step that some practitioners include and others skip. Traditional tung oil or modern tung oil alternatives are applied sparingly to the brushed surface after cleaning, and the oil penetrates the carbonized layer slightly and stabilizes the soot against handling and weather exposure. Without oil, the surface is more vulnerable to abrasion from handling during installation and may shed carbon dust until it is well weathered into service. While with oil, the surface keeps a slightly darker, more uniform look over its service life and is more pleasant to handle during and immediately after installation. Both finishes age into stable, low-maintenance surfaces that do not require repainting or restaining in normal service conditions, which is one of the key advantages over conventional siding options that require periodic maintenance to remain aesthetically acceptable. Cost comparison with high-end conventional siding is interesting for anyone planning a project. Premium fiber cement siding in fully installed form runs in the order of a few tens of dollars per square foot in many North American markets, while Shou Sugi Ban cedar supplied and installed professionally runs in a similar range with somewhat higher labor costs due to the on-site charring step. Pressure-treated pine or fir, the lowest-cost fire-resistant option, runs substantially less than either of the premium options, but with different aesthetic and chemical resistance properties that some owners find unacceptable for health or environmental reasons. The cost premium for Shou Sugi Ban versus chemical pressure-treated siding has narrowed as the technique has become more commercially available, and as DIY torch access has improved, which has put the technique within reach of a much wider set of projects than was possible even a decade ago. The fourth and most consequential part of this story covers the actual fire resistance test that has been performed by independent researchers, by design school laboratories, and by material certification bodies on commercially produced Shou Sugi Ban products under controlled burn conditions. A standard demonstration builds two identical small wall sections, one clad with untreated cedar siding and one clad with Shou Sugi Ban cedar siding of the same thickness. and applies a controlled flame source to both walls simultaneously to compare the time to ignition and the time to penetration under identical exposure conditions. The untreated cedar, under most flame conditions tested in the published literature, ignites within seconds of direct flame contact and burns through its cross-section within a few minutes, depending on the thickness of the plank and on the intensity of the flame source applied during the test. The charred cedar, by contrast, chars further on its surface under the same flame exposure, smokes as the carbon layer oxidizes slowly and slowly oxidizes, but does not ignite in the same sense under comparable exposure because the cellulose and hemicellulose fuel that drives combustion in untreated would have already been driven off during the original carbonization step. Under extended direct flame exposure, the char layer will eventually be penetrated, and the underlying uncharred wood will then begin to ignite. But the time to penetration is substantially longer than for untreated wood under the same conditions, and the difference is large enough to matter in real wildfire exposure, where minutes of additional resistance can determine whether a structure survives. Thermal imaging during controlled burns confirms the mechanics of the protection quantitatively. On untreated cedar, the heat front penetrates the cross-section and reaches the inner face within seconds to a few minutes depending on thickness and exposure, while on charred cedar the thermal gradient through the section is markedly slower, and the char layer absorbs and radiates heat, but transmits relatively little heat to the interior wood across the test period. After the burning source is removed from the test rig, the charred wall self-extinguishes rapidly because the surface temperature drops below the threshold for self-sustaining combustion in the carbon layer within seconds, while the untreated wall continues to burn until the fuel is exhausted. Independent laboratory testing in the United States, in Japan, and in Europe has produced formal fire assistance classifications for commercially produced Shou Sugi Ban products, and Class A flame spread ratings have been reported for several commercial products on record in the published testing literature. ASTM E84 testing in the United States has produced flame spread indices for properly charred cedar in the low 20s range, which is comparable to fiber cement siding, and is significantly better than most untreated wood siding measured under the same test protocol, with all specific numerical results being those commonly cited in trade publications and in peer-reviewed material testing studies. It is worth noting that manufacturers' data should be reviewed carefully for the specific product and application context, because char depth and wood species both affect the measured result, and because the published testing has been performed on commercial products rather than on every possible combination of species, char depth, and plank thickness. The fifth and final part of this story pulls back from the technical detail to look at how Shou Sugi Ban is being adopted in 2026 architectural practice across wildfire-prone regions, and what the wider implications are for sustainable construction going forward. Contemporary architectural use of Shou Sugi Ban spans high-end residential, commercial, and institutional buildings across multiple continents, and notable projects have used charred cedar or charred cypress as the primary exterior cladding on single-family homes in California, in British Columbia, and in Australia. Commercial facades in major North American and Japanese cities have used charred cedar as the primary cladding material, sometimes covering multiple stories of a single building, and museum and gallery projects in Europe have used charred oak and charred pine to give institutional buildings a low-maintenance exterior that does not require repainting over the life of the building. The aesthetic is sometimes subtler in these contemporary projects, using partially charred surfaces that retain more of the natural wood color in alternating pattern, or using carefully graded char depth across a facade to emphasize natural light gradients across the day. Maintenance requirements are notably low across all of these applications because properly charred and either oiled or naturally weathered cedar cladding does not require repainting, does not require restaining, and does not require retreatment of any kind under normal weather service conditions over decades. The carbonized surface patinas gracefully over time, slowly transitioning from deep black toward a graphite gray with visible grain emergence. And this living patina is for many owners part of the appeal because the siding evolves visibly with the seasons and with the years, but never looks degraded or in need of repair in the way that conventional painted siding does after a similar period of weather exposure. The integration with 2026 and later sustainable architectural trends is structurally favorable because Shou Sugi Ban is, in its traditional form, a wholly natural material, Wood char with optional natural oils, no synthetic retardants, no chemical leaching of any kind, and no end-of-life disposal issues beyond standard wood disposal. It is locally sourced in many markets because suitable cedar, cypress, and pine are commonly available regional species. It is durable with service lives reported well beyond 50 years in century-old examples in Japan that are still performing their cladding function. And it is end-of-life biodegradable in a way that pressure-treated lumber and fiber cement siding are not. As building certification frameworks in 2026 increasingly emphasize natural materials, chemical-free treatments, and life cycle durability, Shou Sugi Ban fits the criteria well and is being adopted by architects and builders who are under client pressure to meet those certification standards without sacrificing aesthetic quality. The final verdict is straightforward. Yes, this 18th-century Japanese technique deserves serious consideration as a fire-resistant, chemical-free, low-maintenance exterior cladding option for residential and commercial buildings, particularly in wildfire-prone regions where the fire resistance property is not just a marketing claim but a real safety outcome. Its limitations are clear and should be acknowledged in any project decision. It is not appropriate where a painted or non-black aesthetic is required for design reasons. It requires skilled installation that is not as widely available as conventional siding installation. And it is more expensive than the cheapest conventional options, even after the cost premium has narrowed over recent years. But the combination of fire resistance, pest resistance, hydrophobicity, and process simplicity that Shou Sugi Ban delivers is unusual in the building products market, and has not been matched by chemical alternatives that carry the environmental costs those alternatives impose, which is the reason the technique has crossed from a niche Japanese craft tradition into a global sustainable construction option over the last decade. For the right architectural context, with the right aesthetic tolerance, and with skilled tradespeople available to install it, Shou Sugi Ban is an unusually complete answer to a common construction problem. And the underlying chemistry of why it works is simple enough that any project can evaluate it on its actual performance rather than on marketing claims.